Welcome to the deep dive. Our mission, as always, is to cut through all the noise and get straight to the essential insights, the things you really need to know. Today, we're taking maybe a slightly different angle to understand Cloud Pak for data. We're actually using an exam guide as our map because, those exam questions, they often zero in on the absolute core critical knowledge points, the stuff you really have to get.
That's a great way to look at it. Yeah.
So think of this as your shortcut, really, to understanding a pretty complex system. It's designed for anyone who wants to get up to speed quickly on what truly matters.
Exactly right. And for anyone maybe less familiar, Cloud Pak for Data, it's this powerful unified platform. Its whole purpose is bringing data and AI capabilities together. So this deep dive, using that exam instruction you mentioned, it's going to give you a really clear view of the critical parts of implementing it. We're going to touch on, well, pretty much everything, from the foundational planning, the nuts and bolts and the crucial security requirements, all the way through architecting with AI services, analytic tools, data governance, which is huge, and integrating different data sources. Our goal really is to pull out some surprising facts and key things to think about across all these areas, make it accessible, no matter your technical background.
Okay, let's unpack this then. So imagine you're starting out looking at something as big as a Cloud Pak for data implementation. Where do you even begin with let's say, the physical backbone, particularly storage?
Right. Well, the absolute first thing, the primary consideration for storage architecture.
Yeah.
It isn't just, picking a big hard drive, not at all. It's about meticulously evaluating the performance needs.
Okay.
So we're talking speed, throughput, latency, all that, and also the data retention policies. But here's the key. You have to do this for each individual service within the Cloud Pak.
Not just overall.
Exactly. And the insight here, maybe a surprising bit, is how often companies either over-provision.
Waste of money.
Yeah, massive cost inefficiencies, or maybe worse, they under-provision because they treat it all the same. And then you get critical performance bottlenecks that just cripple things.
Right.
So it's really about that granular optimization you see, matching the right storage, the right performance to the right workload, not just broad strokes.
That makes perfect sense, that granular approach. Okay, so once you've got your storage sorted, thinking about it service by service, how do you keep the data flowing? Continuously, reliably?
Yeah, good question. For data replication, keeping things in sync, there are a couple of non-negotiables. You absolutely need a robust, stable, high-bandwidth network connection. That's one. And two, you need properly configured source and target databases.
Sounds basic, maybe.
It does sound basic, right? But the surprising truth is how often replication failures actually stem from network wobbles or misconfigured endpoints. It's really common. Think of it like, a critical supply chain. If your transport links are flaky, the whole thing grinds to a halt.
Yeah.
So those stable, high-bandwidth connections, they are just essential for uninterrupted, accurate replication, making sure that critical data is where it needs to be when it needs to be there. No hiccups.
Okay, no hiccups needed. But that brings up another challenge, doesn't it? What if you're not starting from scratch? I mean, most companies aren't.
Right.
What if you're bringing in a whole existing system, like migrating an on-premises Hadoop data lake? That's a big one.
Oh, yeah, that's a very common scenario and definitely challenging. When you're migrating existing data, especially from something like an on-prem Hadoop lake, which is basically just this giant storage pool for big data, the absolute key, the thing you must evaluate first is the compatibility of your existing data formats.
Formats like?
Well, are they using modern, efficient columnar formats, things like Parquet or ORC?
Okay. Now, these aren't just jargon. They're formats specifically designed for high-performance analytics queries. Really important. Checking that compatibility right at the start is vital. It helps you avoid really costly, time-consuming data transformations down the line.
So you don't want to discover halfway through you need to convert everything.
Exactly. Without that upfront check, what looks like a straightforward migration can suddenly balloon into this complex, expensive re-engineering project. Adds tons of time, tons of cost.
Right. Avoid the pain later. Okay. That makes perfect sense. Now, shifting gears a bit, let's talk security. It's obviously paramount in any data environment, but maybe especially one as distributed and complex as Cloud Pak for data. It feels like security here gets layered. complex.
It absolutely does. Take the data virtualization service, for example.
Yep.
It's incredibly powerful, right?
Yeah.
Because it lets you access data from lots of different places as if it's all in one spot without actually moving the data itself.
Virtualization. Exactly. But the critical security requirement here, the thing to really grasp, is that since the data isn't moved, you have to ensure proper access controls and valid credentials for the underlying data sources, where the data actually lives.
Not just securing the virtual layer itself.
Precisely. And the pitfall, maybe the surprising one, is that companies sometimes focus too much on securing that virtualization layer and not enough on diligently managing permissions for the data back at its original distributed source. And that oversight, it can leave these wide open back doors for unauthorized access. Big risk.
That's a really crucial distinction. Secure the source, not just the window. Okay, building on security then. What about preventing a single point of failure? Authentication, getting into the system, always feels like maybe the weakest link sometimes. What's the best strategy there? And maybe what are some challenges companies face actually adopting it?
Yeah, good point. The most effective mechanism, bar none, for preventing a single point of failure in authentication is multi-factor authentication, MFA. It requires more than one way to verify who you are. So, your password plus maybe a code from your phone app or a fingerprint scan, something like that. This massively reduces the risk, even if one factor like your password gets compromised somehow.
Makes sense.
What's truly surprising, though, even today, is how many organizations, even big ones, still haven't fully rolled out MFA across all their critical systems.
Really? Why is that?
Well, the challenge often isn't the tech itself. It's more about user experience concerns or maybe perceived friction for the users. Oh, it's an extra step.
Right.
But honestly, it remains probably the simplest, most impactful defense you can put up against very common identity threats. A real game changer.
Hard to argue with that logic. So, okay, MFA handles who gets in. But what about the trust between components? Behind the scenes, how do all the different parts of Cloud Pak for data talk securely to each other?
Right. That's where a certificate authority, or CA, plays a crucial role. The primary purpose of a CA in a secure environment like this is to issue and manage digital certificates.
Okay, digital certificates.
Yeah, and these certificates are fundamental for two things: authentication, proving who's who, and encryption, scrambling the communication so no one else can read it. Basically, the CA acts as this trusted third party. It builds a solid chain of trust throughout your entire system.
Got it.
Without a well-managed CA, you lose that foundational layer of verified identity and secure comms. And that just opens your system up to all sorts of vulnerabilities you might not even see.
Okay, so security is clearly woven through everything, foundational.
Yeah.
Now, let's shift focus a bit. Once you have all this data, potentially flowing securely from many sources, how do you keep that vast sea of information organized and, crucially, trustworthy? Especially for things like AI and analytics.
Right. That's a huge challenge. And that's precisely where something like Watson Knowledge Catalog comes in. It's a really powerful data governance tool.
Watson Knowledge Catalog, okay.
Yeah. And it's more than just like a fancy data dictionary. It acts as a central hub, really, for discovering data, governing it, managing all your data assets across the whole organization. Think of it like the ultimate librarian plus the rule enforcer for your data.
I like that analogy. Librarian and rule enforcer.
Exactly. What it ensures is that your data isn't just findable, but it's also trustworthy, it's compliant with regulations, it's properly curated, ready to be used effectively in AI and analytics projects. Without something like that, honestly, you quickly end up in data chaos. Makes it almost impossible to build reliable AI models or get accurate insights you can trust.
Yeah, I can definitely picture the chaos without that librarian. Okay, but what if you need more than just finding assets? What if you need a truly complete picture, like a 360-degree view of a customer, consolidating info that's scattered all over the place?
Yeah, that's the main benefit, the core purpose, really, of using Match 360.
Match 360.
Its job is to create that unified, trusted 360-degree view of an entity. That could be a customer, sure, but also maybe a product, a supplier, anything where the data is spread across different systems. It works by consolidating and, crucially, matching fragmented data from all those disparate sources into one single, consistent golden profile.
Breaking down the silos.
Exactly. Breaking down data silos is key. And what's often underestimated, I think, is just how complex it can be to match records from different systems. They might have slightly different spellings, different formats, different IDs.
Okay, this is C data.
Totally. Match 360 tackles that mess head on. And the result is significantly better analytics, much more personalized customer experiences, and just, well, better, more consistent decision making across the whole business.
That kind of unified view sounds incredibly powerful. Okay, so moving into the world of AI and machine learning itself, you've got your governed, maybe even matched data. How do teams actually collaborate effectively when they're building models and AI applications, without messing up each other's work?
That's a critical operational point when you're architecting with AI services like, say, Watson Studio. The key benefit of using dedicated projects and spaces within tools like that is they provide these isolated, collaborative environments.
Like sandboxes.
Exactly like sandboxes, or maybe individual digital studios, places where data scientists and ML engineers can work on their own stuff, or together, without stepping on each other's toes or overwriting experiments or
That
code.
avoids conflict.
It enables controlled collaboration, yes, but also really important things like proper versioning of models and data and crucial environment isolation for development. And maybe a surprising advantage isn't just avoiding conflicts, but also enabling reproducibility, making sure that a model developed by one person or team can be accurately recreated and deployed by another. That's huge for scaling AI.
Yeah, reproducibility is massive in AI. Yeah. Okay, that makes a lot of sense for managing those complex workflows. So finally, what about situations where the connections in the data are actually more important than the individual data points themselves? I'm thinking like social networks, fraud detection rings, complex supply chains, that kind of thing.
Ah, precisely. That's exactly where something like DB2 Graph Services shines.
DB2 graph.
Yes. Unlike traditional relational databases, which are all about tables, rows, columns, DB2 Graph is specifically designed for, well, graph data models. That means it absolutely excels at managing complex relationships and spotting intricate patterns within those relationships.
Okay.
So your example of fraud detection is perfect. You're not just looking at single transactions in isolation, right? You're looking at the network of connections between accounts, devices, IP addresses, locations.
The web of connection.
Exactly, the web. Or in a recommendation engine, it's about connecting users to products through other users they're connected to, or items they've both interacted with. The relationships are key. DB2 Graph lets you analyze these complex networks in a way that traditional databases just aren't built for.
So thinking about all this, what does it really mean for you listening right now as these data systems become more and more intertwined, more foundational to pretty much every industry? How does your understanding of these core principles, the storage details, the security layers, the governance, the specialized analytics, how does that empower you? Does it help you ask better questions, make smarter decisions, or maybe even spot the next big opportunity hidden within today's complex data landscape? Keep exploring.